Okay, this is 2021 FRQ number one. Should usually is in the calculator portion. So I believe numbers 1 and 2 are going to allow you to use a calculator. All right, so let's go ahead and look. This is a chart problem and see what the table wants us to interpret. Number one, the density of a bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by an increasing differentiable function. Again, first thing you want to pick up is the fact that it says it is differentiable. So that means a lot of our formulas is going to work. Well, f of r is measured in milligrams per square centimeters. Values of f of r for selected values of r are given in the table above. Use the data in the table to estimate f prime of 2.25. Using correct units, interpret the meaning of your answer in the context of the problem. Okay, so I'm looking for the derivative of 2.25. So looking at my chart here, what I have are y and x and y values. So that tells me I'm going to use mean value theorem, or basically I'm going to use the slope, right? So I have this point here and this point here. And I can use y2 minus y1 over x2 minus x1. So f of 2.5 minus f of 2 all over 2.5 minus 2. So what's f of 2.5? The value is 10 minus 6 over 0.5. This will give you 4 over 0.5, and we have 8. 8 what? So this is 8. So this is your y value over your x value. So it will be milligrams per square centimeters per centimeter, right? So it's milligrams per square centimeters per centimeter, or you can say it's 8 milligrams per centimeters cubed. So this is a rate of a rate, right? So rate of a rate of a rate of a rate of a rate. So lots of rates here. Okay, the total mass in milligrams of bacteria in the petri dish is given by the integral expression 2 pi integral from 0 to 4 r f of r dr, approximate value of 2 pi of the integral using a right Riemann sum with the 4 subintervals indicated by the data in the table. So we can't use this directly because it asks us for r f of r. So what that means is it's a lot easier if you create another row of values. If you already see it, you don't have to, but I find it easier, so I go r times f of r. So I basically multiply these two values together to create my next row. So I have 0, 2, 12, 25, and 4 times 18. That gives me 72. Okay, all right, there's my new row there. It's a lot easier. Okay, so it wants me to use a right Riemann sum, so RAM, to estimate this part right here, this integral here, right? Because I don't have a function. So RAM means that I don't use the first. So that means then looking at the distance between these two, so that's 1. So the integral 0 to 4 r f of r dr is equal to 1 times the right endpoint, which is 2, plus between 2 and 1, that's 1, the width of 1 again, and then the right endpoint is 12. And then between these two, that is the difference of 0.5, right endpoint of 25. And last but not least, the difference between these two is 1.5 times the endpoint of 72. Okay, so that gives me 2 plus 12. This one gives me 12.5. And then 1.5 times 72, that is 72 plus 36. That gives me 108. So that gives me 110, 122, 134.5. Don't forget to multiply by 2 pi, right? This is, actually, why am I doing this by hand? This is a calculator portion, so you can definitely use a calculator. So 134.5 times 2 pi gives me 845.088. Don't forget your unit, your rounding, so 3 decimal places. And what does this give me? The total mass in milligrams. So this is your total mass in milligrams. All right, put my units there, don't forget. Okay, is the approximation found in part B an overestimate or underestimate of the total mass of bacteria in your petri dish, right? So your function is your r f of r. So you're trying to figure out, hey, is this an overestimate or underestimate, right? So you need to figure out if the derivative of this is going to be a positive or a negative. So let's go ahead and look. We're going to take the derivative of my function ddr of r times f of r, right? Don't forget this is product rule. The derivative of r is 1 times f of r, so 1 times f of r plus r times f prime of r. Okay, so let's see. F of r, what do we know about f of r? Well, f of r, this function f of r, if we look at the data table here, your value here is increasing the whole time. So I know that's going to be increasing. So this is writing myself a little note. This is increasing. Okay, and then r, let's see, what is r? R values are all positive because this is a radius going out in the Petri dish. There's no negative radius. So r is always going to be positive. So this is positive. Okay, what about f prime of r? Well, f prime of r, if you look at your data table up here, so if you look at your part A here, you can see, and you can do this quickly too, because your f of r value is increasing, your f prime, meaning your slope, at any of these points is still positive because you're going up, it's increasing, right? Could be increasing slowly, slower at some points than others, but this is still increasing. So this f prime of r is also positive. So you're positive, positive, increasing. Therefore, this whole thing is increasing. Right. So if it's an increasing function, right, your increasing function this way, increasing functions this way. So whether increasing functions this way or this way, whether it's concaving up or concaving down, doesn't matter. Your RRAM is going to look something like this. Your RRAM is on the right-hand side. So here's your RRAM, right? RRAM is going to look like this. So you notice all your RRAM is always going to be an overestimate because it's an increasing function. So that means it's an overestimate. Okay. All right. Last one on this problem, last part on number 1. It says the density of bacteria in the Petri dish for radius between 1 and 4 is modeled by a function g defined as g of r equals this nice function. Well, what value of k between 1 and 4 is g of k equaling to the average value of g of r on the interval of 1 to 4? So first thing you want to figure out is the average value, right? So it says average value. That's a hint. Average value, and you have a function like this. You are looking for the mean value theorem. You're getting the MVT. So average value is equal to the integral between 1 to 4 of g of r dr. And oops, sorry, I forgot my most important thing. I forgot my 1 over b minus a. So 1 over b minus a integral 1 to 4 g of r dr. Okay, put this all in your calculator because you can. You're going to get a nice long answer of 9.875. Choose a few more decimals because you might need, you're looking for the intersection of this, so it's going to be a little bit tougher. It's going to be more rounding errors if you round it off right now. So more decimals here, okay? So you're saying for what values is g of k equaling to this average? So g of k, so you're looking for when this function is equal to that, right? So when is g of k equaling to 9.875795? So what you want to do is graph this on the calculator. Graph this as your y1 and graph this as your y2. Look for where they intersect, and you should be able to find that intersection or your x value, k value. So your x value or your k value is equal to 2.497017. So make sure you check and see that you do truly get that. Okay? All right.